Hello, a problem. So this was number 12. So I'll use the mass point to do this question. So we are given a triangle, and then there are some segments like A, D, like B and C. And the sum of ABC is 43, and what we want is the product of ABC. So it's quite challenging, to be honest. There is not really much numbers given. So only thing is we have is like D is 3, and then sum of ABC is given. So we want to find the product. So if you have no idea about the mass points approach, which is actually quite useful in a lot of cases, and this is one of the cases I'm going to use it. So for us to use the mass points, we start assign some masses into some like vertices. I'm going to start with A. So I'm going to assign this guy to be X as the mass. Okay, and then I'll assign B as Y, and then this is Z. So when you assign the masses, like, these are the intersection of like this segment and this segment. So this intersection is just the mass point of the X and Z. So which is why I will say the sum of these two masses will be here. So if I'm gonna assign this guy as X plus Z, so that should be X plus Z. And the same idea, this would be Y plus Z, which is the mass. And then this point will be X plus Y. So if you are not sure what I'm doing, so you will probably see soon. So as soon as we assign these masses, and then we just got the mass in those intersection, it doesn't have to be in middle point. So it could be anything on this, like, I guess, side. So we just got the mass for these individual points. So now when we have the masses, like think about like this segment from A to this corner, this vertex. So this mass has a distance of A units from P, and then this mass has a distance of D from this vertex. So the product of those two masses and the distance are going to be equal. That's the whole point of the mass point approach. So the X times A, or A times X, X times A is equal to D times Y plus Z. Okay, and if I use the same thing as like this line segment, so the B times Y, okay, equals D times X plus Z. And the same thing with this segment. So I'm going to go with C times Z. C times Z equals D times X plus Y. Okay, so we have these so far, but no, we are given the sum of ABCs. Maybe we should find the ABCs alone. If I divide the X, Y, and Z from this equation, so you will get A equals like D times Y plus Z and divided by X. And then the same thing with this guy. So the B has to be D times Y plus Z over Y. And then the last one is going to be C is equal to D times X plus Y over Z. So if you add this sum is 43. So let's go ahead and write that. So 43 is equal to, when you look at this is common. So we can pull D as a factor. So which is actually given as 3. So we can replace. So 3 times Y plus Z over X plus Y plus, this was X plus Z, right? Let me double check. B times Y, so B times Y is D times X plus C. So this is X plus C. So this is X plus C. Okay, so for the B1, so we got the X plus C, right? Okay. So the X plus Z over Y. And then for C, it's going to be X plus Y over Z. So Y is the X. Okay, and then this is multiply. So let's keep this for now as it is, because we don't want to do much work unless we really need it. So then we are going to find the product of ABC. So let me write here. So the A times B times C is what we want. You know, the A is D times this, B is D times this, so which means we are multiplying D 3 times when I multiply A, B, C's, which is going to be 3 to the third power, which is 27, times, we are going to multiply these fractions instead of adding. So the Y plus Z over X plus times the X plus Z over Y, and then X plus Y over Z. Okay, so this is the product what we want, right? So if I want to multiply these guys and see what we get, like, but I hope we can kind of see the relation between this and this. So we can just expand this, which I will do that just to see how that looks like. So if I expand this, that will be equal to, maybe I can divide by 3 to get that whole expression itself. So that is 43 over 3. So if you multiply y by x and x, you get yx squared. If you multiply y, x, and y, you get y squared x, which means you're going to have those like the pairwise product twice, and you're going to get that twice for each of these different pairs. And then one of them will have power of 2, the other one have power of 1. So if I just kind of do that, so I can just like multiply here, but you know, we are adding these guys. In this case, we are multiplying, so we just want to kind of multiply this anyway. So if I multiply this by yz, and then this is xz, and then this is xy. So the first one would be like y plus z times yz, which is going to be y squared z, plus z times this, which is y z squared, plus, and then if I multiply this, you will get x squared z, and then you will get z times xz, which is xz squared. As you see, everything is going to be double, so you will get the, I mean, not double, but you are going to get like y squared z and y squared x, and then you are going to get all these symmetric basically. So if I multiply this guy, so you will get x squared y, and then xy squared. So this is what we have, right? So we have 1, 2, 3, and 6 terms. And then this is all over divided by x, y, z. And then this is given as 43 over 3. So if I expand the other guy, which is what we want, I hope we are going to get really similar expression so we can get what we want. So let's simplify this. So 27 times. If I multiply the y by x, you get yx squared, which is like one of these terms. Y by x by this, you will get one of these terms. But if I multiply these, you see, if I take y right here, x right here, and like, I don't know, this guy right here, you get one of these terms. But if I multiply like y here, z here, x here, I get x, y, z, which wasn't part of the numerator. Also, I can take z right here, x right here, and y right here, which means x, y, z in that product actually going to be twice. So if I kind of expand those, so you will get 2x, y, z plus all these terms is going to be produced from this product. So I'm going to say whatever this numerator is, I'm going to call that whole thing is kind of A, because that's what you are going to get. And all over divided by x, y, z. So again, I just named this guy as A because I don't want to write it. And we are lucky because we kind of know this A divided by the XYZ as 43 over 3. And also there's a bad guy right here. Like if I expand this to XYZ divided by XYZ, that will be just 2. So this is going to be equal to 27 times 2 plus A over XYZ. And then A over XYZ is this fraction. So if I plug that, so we are going to get 27 times 2 plus 43 over 3. And if you multiply this, you will get 441. So this is a question where, like, you know, we didn't really do much work. So to be honest, you can try this question a couple different ways. Maybe if you know about the COS theorem, so you can try that as well. But I just want to use the math point, even though we don't really have a lot of like ratios given in the problem, because that's usually the hint that we use to kind of apply the mass point. But now we do have another question where we don't really have that ratios going on, but we still get the mass point approach useful because we do have a lot of variable, and then we can just write as a fraction. So that was the kind of the hint that I used. So I hope that was clear. So I'll see you in the next video.